Hello students, how are you all? I hope you are doing absolutely good. So, we are discussing about our chapter, that is the class 10 chapter electricity, and this is a very important chapter because the weightage of this chapter from your syllabus is very large. Most of the questions will arise in your exam, in your competition exam also from that is of the NTSE and Olympiad level. So, we were discussing about the electricity, and until now we have discussed about the electric charges and their properties. So electric charges are basically the carriers which is going to constitute an electric current. Now in our today's lecture we will discuss about few more terms and few more units that are related to these physical quantities. So let's begin the chapter here, that is about electric current. So our next topic of discussion will be about electric current. Now, as we have discussed in our previous lecture that always some carriers are needed for constituent a current. Similarly, like electric current, river current is formed when there is a water in a river. Similarly, air current is formed when there are in air we have the different amount of the gases or different amount of the particles we have. Now, electric current is basically produced when the charges are available. So, electric current is actually the flow of a charges per unit area in a specified amount of time. It means किसी पर्टिकुलर टाइम में किसी पर्टिकुलर एरिया में कितने चार्जेस फ्लो हुए. इट मीन्स एक सिस्टम से एक बॉडी से दूसरी बॉडी तक जो अमाउंट ऑफ चार्ज कितना फ्लो हुआ वो क्या कहलाएगा, वो कहलाएगा इलेक्ट्रिक करंट. सो व्हाट विल बी द डेफिनेशन फॉर इलेक्ट्रिक करंट? It is defined as the amount of charge flowing in a unit time from a particular area. So, let us write the definition here. It is defined as the amount of charge flowing per unit time in a particular area, or we can say that it is the flow of charges from one conductor to another, and that conductor could be metal also. Now this is the amount of charge. What we have discussed, this is the amount of the charge. So, amount of charge flowing per unit time. So, I can write that electric current is basically denoted by the symbol I. What is the symbol for electric current? Electric current is usually denoted by the symbol I. So, I can write I is equal to Q upon T. It means it is the amount of charge flowing per unit time from a particular cross-sectional area. So, this will be the formula for electric current we have. This is a very important formula. Sometimes numerical can be asked, that is depending upon this formula. Now, let us see the diagrammatic representation we have regarding this. Now, what I have drawn here, you can see that there is a particular cross-section area. So, this is our cross-sectional area. and these pink color that has been drawn, these are the electrons actually. So this is the amount of charge we have. I can write here, this is the amount of charge I have. Now this amount of charge flowing in a particular time, so I am assuming that the time is t. So from this particular cross sectional area, the amount of charge that is flowing per unit time will going to tell you the current. So again, current is denoted by the symbol I, and it is defined as the charge flowing per unit time from a particular cross sectional area. Now this is the symbol and this is the formula for calculating the current. Now what will be the units for calculating the current? So let's discuss here the units for current. So the current, a unit of current can be identified from this basic formula. So we have I equal to Q upon T. Now tell me, what is the unit for charge we have? We have discussed previously that the unit of charge will be coulomb and the standard unit for time will be second. So I can write here that for charge we have a unit coulomb and for time we have a unit that is second. So these are the standard unit of Q and T. So I can write that unit of current will be coulomb per second, or I can write coulomb second inverse. These are the units that we are getting from here, and for that I, we have one standard unit that is known as coulomb per second and the unit is specified as ampere. So the standard system, in the international system, the unit of current is defined as a ampere. So what is the standard unit here? Ampere. Now करंट की जो यूनिट है उसका नाम एम्पियर क्यों हुआ? क्योंकि जो डिस्कवरी थी करंट की उस टाइम पे एक फ्रेंच फिजिक्स थे जिनका नाम था एंड्री मैरी एम्पियर. उनके नाम के बेसिस पे करंट की यूनिट क्या दी गई? एम्पियर. सो एम्पियर इज एक्चुअली अ नेम ऑफ साइंटिस्ट वी हैव. सो द स्टैंडर्ड यूनिट ऑफ करंट विल बी एम्पियर and we can also write coulomb per second, and it is gave after the name of a French physics, that is Henri Marie Ampere. Now किसी भी सिस्टम में जो यूनिट ऑफ करंट होगा वो 1 एम्पियर कब कहलाएगा? हम कब कह सकते हैं कि किसी भी कंडक्टर में जो करंट फ्लो हो रहा है वो 1 एम्पियर है? सो व्हाट इज 1 एम्पियर करंट? सो व्हाट इज 1 एम्पियर करंट? Now 1 ampere current is defined as a 1 coulomb charge that is flowing through a conductor in a 1 second. It means 1 coulomb charge 1 सेकेंड में अगर फ्लो करता है तो हम ये कहेंगे कि कितना करंट फॉर्म हुआ? 1 एम्पियर करंट फॉर्म हुआ. सो द आंसर फॉर दिस क्वेश्चन विल बी अ करंट इज सेड टू बी 1 एम्पियर. A current is said to be 1 ampere if 1 coulomb charge is flowing through any conductor in 1 second. अगर किसी भी कंडक्टर में 1 coulomb चार्ज फ्लो होता है 1 सेकेंड में, तो हम ये कह सकते हैं कि सर्किट में करंट कितना फॉर्म होगा? करंट फॉर्म होगा 1 एम्पियर. सो दिस इज द बेसिक थिंग्स अबाउट द इलेक्ट्रिक करंट एंड वी हैव डिस्कस्ड अबाउट द यूनिट ऑफ इलेक्ट्रिक करंट. नाउ हर चीज की कोई ना कोई पर्टिकुलर डायरेक्शन होती है, तो इट मीन्स करंट की भी कोई ना कोई डायरेक्शन होगी. हम कैसे जज करेंगे कि करंट ईस्ट में जा रहा है, वेस्ट में जा रहा है, अपवर्ड जा रहा है, डाउनवर्ड जा रहा है? सो वी हैव टू आइडेंटिफाई द डायरेक्शन ऑफ द करंट. सो लेट्स डिस्कस अबाउट the direction of the current here. So our next topic will be about direction of electric current. नाउ इलेक्ट्रिक करंट की डायरेक्शन क्या होगी? इट मीन्स जब इलेक्ट्रिसिटी की डिस्कवरी हुई थी तब हमारे पास डिस्कवरी ऑफ इलेक्ट्रॉन से रिलेटेड कुछ नहीं था. इट मीन्स हमने ये माना कि इलेक्ट्रिक करंट इज बेसिकली द फ्लो ऑफ चार्ज. इट मीन्स इट इज बेसिकली अ फ्लो ऑफ इलेक्ट्रॉन्स इन अ कंडक्टर. लेकिन जब हमारे पास इलेक्ट्रिसिटी की डिस्कवरी हुई देन that time we do not have any clue about the discovery of electrons. So at that time what was believed that the direction of the positive charges will be the direction of electric current, because at that time the electrons were not discovered. So earlier time में ये माना गया कि conventionally हम इलेक्ट्रिक करंट की डायरेक्शन को क्या अज्यूम कर सकते हैं? हम ये अज्यूम कर सकते हैं कि जिस डायरेक्शन में पॉजिटिव चार्ज फ्लो हो रहा है वही डायरेक्शन इलेक्ट्रिक करंट की होगी. लेकिन इलेक्ट्रॉन की डिस्कवरी के बाद हमने ये मॉडिफाई किया कि जो करंट की डायरेक्शन है वो जस्ट अपोजिट है टू द रेट ऑफ द फ्लो ऑफ इलेक्ट्रॉन्स. सो इट हैज द सेम मीनिंग. अगर हम बात करें अपोजिट टू दैट ऑफ द इलेक्ट्रॉन्स तो वो पॉजिटिव चार्ज होगा, और अगर हम माने इन द डायरेक्शन ऑफ पॉजिटिव चार्जेस तो दीज आर द सेम थिंग्स. बट बिफोर देयर इज नो डिस्कवरी ऑफ इलेक्ट्रॉन्स, सो द कन्वेंशनली direction of the positive charges will be considered as a direction of the current. So electric current is actually flow of electrons. Electric current is a flow of electrons, and electrons are our negatively charged particles. But in earlier times when there is no discovery of electrons, direction of positive charge is considered as a direction of current. But after discovery of electron, the direction of the current will be found as a direction opposite to the rate of the flow of electrons. So I can say that direction of current is equal to opposite to that of the flow of electrons. So this will be the exact direction for the current, that direction of current will be opposite to that of the flow of electrons. जिस डायरेक्शन में इलेक्ट्रॉन फ्लो करेंगे हमेशा करंट की डायरेक्शन इलेक्ट्रॉन्स की फ्लो के डायरेक्शन की अपोजिट होगी. सो नाउ लेट्स कंसीडर अ डायग्रामेटिक रिप्रेजेंटेशन वी हैव हियर. Now, this is a schematic representation of some of the symbols we have used in the electric circuit. These symbols we will discuss in our next lecture. There are many more symbols, but here I am using some symbols, so I am specifying these symbols here. So this is an electric circuit. What is electric circuit? We will discuss the definition now, but before that, let's have a conceptual idea regarding this circuit. This is a source, that is a source will be a cell or a battery we have, and this longest terminal of a battery or cell is known as the positive terminal. This is our positive terminal and this is our negative terminal. So this is our battery or a cell. So I can write here, this is our battery or a cell. This is a key. A key, when pressed, the circuit will be on, and when the key is put off, the circuit will be closed. So we can say that this is a key. Now, this is the bulb we have attached. When we switch on the key, the bulb will start glowing. When we switch off the key, the bulb will not glow. So this is the bulb we have. And this A is our ammeter. Ammeter is basically used to measure the electric current. So the device which is used to measure the electric current is known as ammeter. So this A will be our ammeter. So these are the specification of the few of the symbols that I have used in this circuit. Now, as soon as the key is pressed, जैसे ही हम की को प्रेस करेंगे तो क्या होगा, इस बैटरी में से चार्जेस फ्लो करना स्टार्ट करेंगे. इट मीन्स देयर विल बी द फ्लो ऑफ द पॉजिटिव चार्जेस, इट मीन्स देयर विल बी द फ्लो ऑफ इलेक्ट्रॉन्स, बट द डायरेक्शन ऑफ द करंट विल बी गिवन बाय फ्रॉम द पॉजिटिव साइड. So this will be our the direction of our current, and the current will be denoted by the symbol I that we have described earlier. So as soon as the key is pressed, the circuit is complete. The electrons will flow from here. This is the direction of the current we have. So the direction of electrons will be from here. This is the flow of electron. It means electrons जो होंगे वो इस डायरेक्शन में फ्लो करेंगे. दैट्स वाई हमने ये कहा कि करंट की डायरेक्शन जो है वो फ्लो ऑफ इलेक्ट्रॉन की जस्ट अपोजिट है. अब as soon as the current start flowing in the circuit, the bulb will glow. This bulb will glow and we will detect the amount of current by using this ammeter. So this is the electric circuit we have. As soon as the key is put off, अगर हमने इस की को ऑफ कर दिया तो जो सर्किट होगा वो ब्रेक हो जाएगा. इट मीन्स इट विल स्टार्ट बिहेविंग एज अ ओपन सर्किट एंड नो करंट विल बी flown from this direction, and this bulb will not going to show any emission, and the amount of current noted here will be 0. It means if the bulb will not glow, ammeter will not going to show any deflection in the circuit. So this is about the electric circuit we have. So what will be the definition of electric circuit now we have? So our new term is about electric circuit. अब electric circuit क्या होता है? Electric circuit is basically a circuit which is showing a continuous flow of charges in a particular order, so without breaking. So we can write that the continuous flow of charges in a conductor without any break is known as electric circuit. तो ये कहलाएगा हमारा इलेक्ट्रिक सर्किट, क्योंकि ये कंटिन्यूअस पाथ है. अगर हमने की को प्रेस किया है, इट मीन बल्ब ग्लो करेगा, सो इट विल बी अवर क्लोज सर्किट. अगर हमने की को प्रेस नहीं किया है तो सर्किट विल बिहेव लाइक अ broken circuit and it will behave as an open circuit here. And in the open circuit, there will be no flow of electrons. So there will be no idea of the current we are getting in the ammeter. So this is about the electric circuit we have. Now we have discussed about the direction of the electric current. We have seen the electric circuit we have. Now there are some units in which if we want to calculate the small amount of the charges, we have few units also. So let's discuss these units here. But before that, you can copy it from here. So now, if I have to calculate the small amount of the charges, it is not always possible that the charge or current is very big. So if I have to calculate the small amount of current, what units I will use? I will use the units that is milliampere and microampere. So for calculating the small amount of current, we have two units, milliampere, and the second unit we have is microampere. Now this milliampere will be denoted by the symbol small m capital A, and microampere will be denoted by the symbol like this. Now 1 milliampere will be equal to 10 raised to the power minus 3 ampere, and 1 microampere will be equal to 10 raised to the power minus 6 ampere. So these are the conversion formulas we have, and we will use this conversions in the numericals. Milli means 10 raised to the power minus 3 and micro means 10 raised to the power minus 6. So these are the two conversion units we have. Now let's see that how will be the flow of charges taking place in any conductor. So our next topic is about flow of charges in any conductor. So for this, what we have taken a two charged bodies. Now, we have to discuss the flow of charges in a conductor. So what we have done, we have taken two systems. The two systems are A and B. The body A is our positively charged and the body B we have is negatively charged. Now, what we will do, suppose we have to make the flow of charges from one body to another. So we have taken two systems here, that is A and B, and we have kept them on a insulated stands. Now, if I will connect these two systems through a wire, suppose I am connecting these two systems through a wire. So we have used a wire and connected two systems. Now what will happen if we have to apply the flow of charges from one body to another? It means अगर हमें flow of charges को observe करना है, flow of current को observe करना है, तो we have to kept these two bodies at a different potential. क्योंकि कोई भी चीज तब flow करती है जब उनके बीच में कोई potential difference हो. Now you will ask me, ma'am, what is potential and what is potential difference? So this will be our next topic in our further session. But if we want to flow this current or this charge from this system to this, I have just connected a wire between A and B, and the flow of the charges will take place only when there will be the potential difference between the two systems. So this is a very important note. You have to remember that current will flow only when there is a potential difference. It means current कब flow करेगा? जब दो systems के बीच में potential difference होगा, and this is a very important note. Now, जो पॉजिटिवली चार्ज बॉडी है उसको हमने हायर पोटेंशियल पे रखा है. इट मींस इस वाली बॉडी का जो पोटेंशियल है वो हायर है और जो दूसरी वाली बॉडी है उसका पोटेंशियल लो है. तो जब हमने यहां पर एक वायर कनेक्ट की तो जो फ्लो ऑफ चार्जेस होगा वो कहां से होगा? It will always flow from higher potential to the lower potential. That's why the potential difference is created and current will start flowing in the circuit. So, एक body higher potential पे है, एक body lower potential पे है. तो current जो होगा वो start करना flow करेगा from A to B. So, this is how the mechanism of flow of the charges basically works. Now, we will see a flow of charges in any metal we have. So, just copy it from here so we can proceed to the next part we have. So now, let us see that how the current flows in any metallic wire or any metal we have. So now the question here is how the current flows in a wire. Now, अभी तक हमने ये देखा कि करंट जो है वो क्या है, फ्लो ऑफ चार्जेस है. करंट एक्चुअली फ्लो ऑफ चार्जेस है. इट मींस चार्ज कौन से होंगे, चार्ज होंगे इलेक्ट्रॉन. जब इलेक्ट्रॉन्स का फ्लो होगा तभी करंट का फॉर्मेशन होगा. अब हम ये कंसिडर कर रहे हैं कि एक सिंपल वायर में करंट कैसे फ्लो करता है. सो लेट्स अगेन डू अ डायग्रामेटिक रिप्रेजेंटेशन हियर. So this is our metallic wire, or we say simply this is a wire. Now you can see that if the electrons are present in the system, these electrons are moving here and there in a random manner. It means if there is no supply to the system, if this is not connected to an external battery, the electrons will behaving in a random fashion and they are moving here and there. It means we cannot judge the direction of a current from here because there is a no source of battery provided here. So this is the system, or this is the wire in which there is no external supply. So this is our first case without any supply. So what we are observing in this case, when there is no supply of the electric current, electrons are moving here and there in a random manner. Electrons are moving here and there in a random manner. It means electrons are moving here and there in a random manner. So this is our system first. Now what I am doing, I am connecting this wire with a source of a battery. So again we will draw this wire. Now, this is the second system in which we have connected the metal wire with a battery. Now, what is the difference between these two systems we have taken? That in the first case, if we are not using any source or battery, you can see that the electrons are moving in a random fashion. But as soon as the battery is connected, as we switch on the key, you can see that electron will start flowing from negative to positive. It means the direction of the current, it means it may be the flow of the positive charges. It will take place from this point to this point. It means if a battery is connected, electrons will going to flow in a particular direction. They will not moving here and there randomly. So particularly we will get a specific direction of current, or I can say that It may be from point A to B. So this is the direction of the current is achieved when you connect an external supply here. So this is about the flow of charges in an electrical battery we have seen. So this lecture is over for today. In this lecture, we have completely described about the electric current, electric circuit, and how the electric current flows in a circuit. So this lecture is over for today. Thank you so much and have a nice day.